So sometimes you want to solve something. Let's say there's a story of a guy called Logarithm, you know? So Logarithm, let's just call him shortcut log. Log can have any base, which means can have base 10, can have log of base 1, log of base 2, log of base A in general. So since log can have any base, and what does log actually mean? Let's say we have two, just gonna have to write it nicely. We have two, A equates to 4. We know that the value of A is simply 2. However, we do not know how to get there, but there is a simple way of getting it. So we can say 2A is the same as 2 to the power of 2, which gives you 4 again. In that scenario, we know that we just put this guy down to be A gives you 2. However, if we have another scenario where we have 2 to the power of A, and now it's no longer 4, but 3. So if it is 3, we have a different scenario now. We cannot simply say A equates to this specific number. However, we have something called logarithms to express that. So if we have this one, we can actually express it as log of base what? Base 2 of A of 3, sorry. Like base 2 of 3, which is that 3. This will result in A. So basically, log is basically a way of making A the subject. Just gonna write it as sub. Making A the subject. So now let's work with logarithms even in deeper detail. So or in more detail. So we have let's say we have log of base. Usually if we have log base 10, we don't write the base, we just write it as just log base, log alone. Base log of x times y. So in this case, this is called multiplication. I'm just going to write it as multi. That's an L there. So this one simply gives you log of x plus log of y. And then let's go to division. Division. So if you have log of x divided by y, this simply means that it is log of x minus log of y. And then if you have indices, let's call indices. So now this means that you have log of x to the power of n. Now you need to say this is simply as log of x plus log of x until you have log of x n times, right? So you're going to repeat this part until you reach your n times of exponent. So this simply will result in n log of x. So in other words, you can just simply take the n in front of the log. So what if it's in a different scenario for this case, most people get lost here, is if you have log of x to the power of y minus, it's y minus 1. This will simply give you y minus 1 of log of x. And you can simply multiply that log inside the bracket. So you have log y log of x minus log of x. So that will be your final answer then. Okay, so now we are basically understanding the laws of logarithms. So now let's go to another one. So if we have log of base 10, which is 1, this is always 0. It's the same as saying 2 to the power of what? That one, it gives you 1, or 10 in this case. You're saying 10 to the power of 0 gives you 1. So anything to the power of 0 is 1. And now let's look at the other one. So if let's say you have another scenario, I'm trying to think now. Well, let's do questions involving logarithms. So let's say you have 3x equates to 4. This part will basically so you can apply log on both sides. There's 2 ways to solve it basically. If let's say you have the same thing here, equates to 4. So you can either apply log on both sides. So let's say you have now log of 3 to the power of x. Just put it in bracket, equals to log of 4. So now this part will result in basically your x going in front. So you want to make the x the subject. So it's log of base, log of 3 equates to log of 4. So note that you want to make x the subject. So you simply have to divide both sides by log 3. So that one cancels that one. So you have log of 4 divide by log of 3. So that's your simplified answer. So you can simplify this one as 2 log of 2 divide by log of 3. That will be a simplified version of the answer. I'm not going to work out what that is in decimal. Or you can do the shorthand method, which is the log of base 3 equates to 4 equals to x. Now that's your final answer then. So this one will give you the same answer as that one. Okay, now let's work with lin. What is lin? Now, if we have lin, it's called natural logarithm. Natural logarithm. I think it's logarithm or logarithm, something like that. So that's that's what lin is. So lin is natural logarithm. It has to do with e, which is Euler's number. So if you have log of base e of x, this is the same as ln of x. That's what it is, exactly like that. It is like that. So anything now you have to do from this point is basically just you know that ln is basically a log with the base of e. If you have ln, you know that e is involved. So if you have e to the power of x results in 2, to make x a subject, you can just say it's ln of 2 equals to x. Okay, as simple as that. So now, what are logarithms used for in calculus? A I think you've heard of the product rule, and then and also the quotient rule. Quotient rule. The product rule involved two functions being multiplied together. Function, let's say f of x, it's represented by v and u. And then the quotient rule, quotient is something that you obtain from dividing. So it involves two functions being divided by each other. That's v. So I just need to write as v there. So let's go back to this one. So I just put a fence there to show that these are two rules that we're going to work with. So now we have this first part. The first part is basically the product rule. So the f prime, the f derivative of this rule is given by the f prime of this or the first derivative or the grounded function is given by the product rule, since these two functions are multiplied together, which will be v u prime plus v prime u. So now we have, that's the simple rule, but how do you actually apply this rule and how do you get there? So to get the final answer from there, let's just call this the one part. To get from part one to the first derivative, you need to apply ln on both sides. Or you can apply log, but ln works better. So ln of f of x will result in, just apply on both sides before you do anything. This is u. And then simplified, so this will give you ln of f of x equates to ln of v plus ln of u. Now you need to derive both sides of ln of f of x. This equates to ln of v plus ln of u. I'm putting it as absolute there. I should have put it from the beginning. Like from here, it should have been absolute value of that, because it only take positive from there. Okay, missing another absolute here. However, you need to write it in your when you're trying to solve something. It's very important. Okay, so now we derive this part. So to derive ln, we know that ln, the general derivative of ln of f of x, is taking f of x an example, the derivative will be just the derivative, the derived version of the function on top divided by the original function on the bottom. So we can use this whole principle here, we know. So we have f of prime of x divided by f of x, which is the original one, divided by, equates to v prime divided by v plus u prime divided by u. So now we need to make f of x, f prime x, the subject. So we can say f prime of x will result in the original function times v prime divided by v original plus u prime divided by u original. And this part gives you that. And then you have uv or vu, however order you want to write it. And then you have v prime divided by, can start by u prime plus, because it's plus, so you can change the order a little bit. So this one is u prime v, sorry. And then now you need to just simplify it. So the first part, the u cancel out, you're left with the u prime, v. And then the second part, the v cancels out. So you have u prime, v prime. So now that's your final formula of the derivative of x. Okay. And for your sake, I need you to prove the same thing is true for this guy, which will you prove it exactly like this when you first apply the ln on both sides, and then secondly, you simplify it to its simplest form. That's the second part. And then the third part, you derive it. And then after deriving, you simplify it to that final part. So let's say if you have all of these guys in there, you can get your 4 marks, the total of 4 marks. Total of 4 marks. And then you just need to do this one. So just know that your final equation of this should be f prime equates to the denominator, which is v u prime, minus u v prime divided by v squared. So now let's do some problems involving product. But we don't want to use ln now because we're smarter than that. We know how to use the formula. So let's say we have e to the power of x times cosec of x. That x doesn't look nice. Okay, so now we want to find the derivative of this function. Note that these are two functions multiplied together. So we're going to say let ex becomes u. And then let cosec of x equals to v. So now we have v prime, which is cosec of x is negative cosec of x times cot of x. And then this is v prime, and u prime will result in just ex, because the derivative of ax is just ex. So now we substitute in to get the derivative, and you'll see how simple this is. So you just give each other a chance. So what you can do, most of the time, I used to write them like this. So we have u and v. If you have e to the power of x, and then you have v, which is cos of x, cosec of x. So now your u prime, you write it next to it. V prime, you write it next to it. So this will give you e of x. And then this will give you negative cosec of x. And then this will be cot of x. So the best way to do it is to just cross multiply them, or yeah, basically cross them. And then you just add the answers. So e of x times that one, so it gives you negative cosec. Doesn't matter the order you do it, since it's a product rule. Cot of x. The reason why it doesn't matter what order you do it with is because you have addition in between that formula. The quotient rule, you have a minus in between. So minus, as soon as you swipe minus signs, you have a problem. So, I mean, we know that maths was nicer in grade 2 because you didn't have the minus sign in there. So, yeah. So, okay, now we have to cross the bottom with the top one. So it just becomes e to the power of x times cosec of x. So that will be your final answer. Or you can just simply take ex out, cosec, which will give you e of x cosec of x this will be minus cot x plus 1. I mean, that will be your final answer if you need to simplify, but if you don't need to, it's fine. Just leave it as that, like the top part. This part is fine. Okay, so I focus a lot on the product rule. The quotient rule should follow the same rule, just that you just have to follow. You do the same thing with let's say now for the quotient rule we had where's my quotient rule now? Let's say for the quotient rule you had e to the power of x divided by cosec. Just using cosec as an example today. Okay, so now we're gonna say u is ex, and then v is basically cosec of x, and then u prime is again ex, and then v prime is basically negative cosec x cot x. So now again here you multiply, you cross them, but now be careful because here you start from this is prime. So here you start from bottom up and then from top down. This is strictly the rule. You start from bottom up, number one, where your v is, because your v is your denominator. So you start with the denominator times the numerator, and then you minus them instead of adding. Remember here, you added. Where is it? Where is that cross now? You added. Here you minus them. You minus them. You start here, you go down up. So it will be cosec or e to the power of x. That's the most terrible e I ever written in my whole life. So it will be, I don't know where did that writing come from. Let me just fix that. It's e to the power of x times cosec of x minus, which is that minus sign there. It's part of the formula, which is that one. And then this one will be the top one, which is e of x. E of x, since there's a minus here, it will change that minus into positive. So it will be cos sec of x cot of x. This is everything divided by that bottom part again, cosec squared. So which is cosec x squared. So this will be your final answer. You can take cosec out and ex if you want to. Then that you cancel out with one cosec there. So you have your final answer of ex 1 plus cot of x divided by cosec of x. Just like that. So this will be your final answer for that. Okay, so this is all this video was about the laws of logarithm and how to apply them. Why the product rule is here is because you apply the product rule for finding the derivative and the derivative of both the product rule and the quotient rule. Oh, let me just use another thing as an example. So this example in the past paper I was doing the past few days. So let's say we have fx of cos of x. This thing is raised to sine of x. Now, let's say find find f prime. Most people will just leave this question open on the exam, but this is the easiest question you can find. So it looks very complicated. Even if the sine and cos were switched, it's still very easy. Even if it was tan somewhere there, it's still very easy. If you use this principle, you got everything. So let's apply ln on both sides. You have ln of fx, which is absolute fx, and then equates to ln of cos of x. I see someone is already saying, oh, yeah, that's how you do it. So, and then now you have simplified. So you have sine of x, or ln of cos of x. And now this is ln of f of x. But now most people will say, okay, now I'm just gonna need to do the product rule here and ignore this part. This part, no, you don't ignore it. You have to, if you apply the derivative on this whole function, so this will give you f prime of x divided by the original function. This will always be the case. If you forget that, you will lose your marks. And then this will be the product rule. So remember, if you have u and v, if u is sine of x, and then v is basically ln of cos x. Now, u prime is basically cos of x. Then v prime is basically negative sine, sorry, of x divided by cos of x. Okay, now you still multiply, you cross them here. The order doesn't matter since it's the product rule. So you have sine times sine becomes sine squared. So it becomes negative sine squared x divided by cos of x. And then this is that bottom part times the top part. So it's plus ln of cos of x. Remember, this one is in its own bracket times that other cos outside, cos of x. Are you done? Not yet. So you need to make fx the subject. So you need to just multiply the f function here. Now, note that this part can be written as sine x, which is negative, cot it's not cot, it's sine tan of x, and then it's plus ln of cos of x, cos of x. Okay, now you need to multiply in the original function to get the f derivative. So f derivative of that will be given by, what was the original one? Was cos of x to the power of sine of x times negative. Let's just write ln first since it's positive. Ln of cos of x. And then this will be cos of x minus sine of x tan of x. Okay, so now this is your final answer for your derivative. Was it simple? Yes. Was it hard? I don't know. But in this channel, nothing is too difficult. So this is all you needed to do for the whole function. If you have more questions, I think you can post them in the comment section, and more things that you need to do, please post them in the comment section. And this is the end of this video.